Hello viewers, in today's lecture we are going to study about differential equations. Differential equations play an important role in different uh, fields of science. For example, differential equations are very important in chemistry, in economics, in engineering, and in other fields of science. Now, let us first see what is meant by a differential equation. Clear? Suppose we have uh, a function, say y equal to fx. Now, here y is known as the dependent variable, and this x is known as independent variable. Now, suppose we have dy over dx is equal to, say, x plus y. Clear? Now, this expression is known as a differential equation because this contains the independent variable, the dependent variable, and the derivative of the dependent variable with respect to the independent variable. Clear? So, if we define a differential equation, then we can say that an equation involving derivative or derivatives of the dependent variable y with respect to x is called a differential equation. Clear? I am repeating it once again. An equation involving the derivative of the dependent variable with respect to the independent variable is called a differential equation. Clear? A differential equation involving derivatives of the dependent variable y with respect to this one independent variable is called an ordinary differential equation. It is called an ordinary differential equation. Clear? If we have the derivatives with respect to only one variable, then such an equation is known as ordinary differential equation. But a differential equation involving derivatives with respect to more than one independent variables is called a partial differential equation. Clear? Partial differential equation. We can say that if we have the derivatives, say like del square y over del x del z. Now here y has derivative with respect to two variables. Clear? So such differential equations which involves the partial derivatives like del y over del x or del square y over del z square, then such an equation is known as partial differential equation. Okay, so here's some more examples of ordinary differential equation is, say, d square y over dx square plus x dy over dx equal to, say, y. Clear? Now this is an ordinary differential equation. Clear? Now let us take some more examples of ordinary differential equation. Suppose we have a differential equation of this type, d square y over dx square minus 2 dy over dx plus 4y is equal to, say, cos x. Now this is also an ordinary differential equation. Clear? Now viewers, let us take the order and degree of a differential equation. So let us first take the definition, the formal definition of order of a differential equation. So the order of a differential equation is the order of the highest order derivative, is the highest order derivative occurring in the differential equation. So what is the order of a differential equation? Order of a differential equation is the highest order derivative occurring in the differential equation. For example, suppose we have an equation of the type, say, d square y over dx square plus 2 times of dy over dx plus y is equal to 0. Now here we see that the highest order derivative is the second derivative. Clear? The second derivative. So therefore the order of this differential equation is 2. Clear? Now similarly, if we have an equation of this type, say 3 d cube y over dx cube. Now suppose we have this equation. Now here we see that the highest order derivative is the fourth order derivative. So here the order of this differential equation is 4. Clear? So what is the order of a differential equation? Order of a differential equation is the order of the highest order derivative occurring in the differential equation. Clear? Now let us come to the degree of a differential equation. Viewers, the degree of a differential equation is defined if it is a polynomial equation. If it is a polynomial equation in its derivatives. Now what is meant by polynomial equation in its derivatives? Let us see. Now viewers, here the degree of a differential equation is defined if it is a polynomial equation in its derivatives. Clear? Now viewers, here I have listed out 5 examples where we see that the first equation is a polynomial equation in the derivatives. Clear? Now how this is a polynomial equation in the derivative? Because this can be written as the equation 1 can be written as y triple prime, and then we have 2 times of y double prime raised to 4 and minus y prime and plus 2y is equal to 0. Now viewers, here we see that this equation is a polynomial equation in the derivatives. Clear? Now here we see that in example 2 this equation is not a polynomial equation in the derivative y prime, because here the y prime occurs as cos of y prime. See, here this y prime is it occurs inside this cos or as a cos function. Clear? So we have cos of y prime. So this equation is not a polynomial equation. Okay? So this y prime is not free here. Clear? Similarly, here we see that the second derivative, the y double prime, is it occurs as a log function. Clear? So we have a log of y double prime. So this equation is also not a polynomial equation in the derivatives. Clear? Similarly, equation 4, this is not a polynomial equation. This is also not a polynomial equation. Similarly, 4 is also not a polynomial equation in the derivative. Why? Because here the y prime occurs as a power of this exponential number. Clear? So here we have y prime, e raised to y prime plus 3y is equal to 0, and this equation is not a polynomial equation in the derivatives. So therefore this is also not a polynomial equation in the derivatives. Now this is a polynomial equation. Now equation 5 is a polynomial equation in the derivatives. Clear? Now here I would like to mention or I would like to revise what is a polynomial. See, what is a polynomial? A polynomial can be written as a naught here a1 x raised to 1, a2 x square, a3 x cube, and an x raised to n. So this is a polynomial, say p of x. Clear? Now here we see that for these x, the variable x, we have to be we have to see that the given differential equation is a polynomial equation in its derivatives. So x or this variable x is replaced by the derivatives. Clear? Is replaced by the derivatives. So we see that in 2, 3 and 4 these equations are not of this form. Clear? In the derivatives, but equation 1 and 5 are the polynomial equation in its derivatives. Clear? So therefore in case 1 and 5 the degree is defined. Degree is defined. Clear? And in case 2, 3 and 4 the degree is not defined. Clear? So we can say that degree of a polynomial of a differential equation, if it is defined, is the highest power of the highest order derivative in it. Clear? I am repeating once again, the degree of a differential equation, if it is defined, provided it is defined, is the highest power of the highest order derivative present in it, and the degree is a positive integer only. The degree is a positive integer only. Clear? So here the degree of this differential equation is 1. Here the degree is 1. Why? Because the highest order derivative is the third derivative here, and the highest power of this is 1. So the degree is 1, and order of this differential equation is 3. Clear? So order is 3 while the degree is 1. Clear? Similarly, in case 5, the order of this differential equation is 3 and the degree is 1. Sorry, it is 2. Clear? So this is 2. So I am repeating once again. So degree of a differential equation, provided it is defined, is the highest power of the highest order derivative present in it. Clear? Now viewers, let us take these 5 examples to understand how to find the order and degree of a differential equation. Here I would like to mention that the degree of a polynomial, the degree of a differential equation is defined only when the differential equation is a polynomial equation in derivatives. Okay, so let us take the first question. So here the differential equation is given as 3 times d2y over dx2 plus 5 dy over dx cube equal to log x. Clear? Now here the order of the differential equation is the order of the highest derivative. So here we have the order as 2. Clear? And what is the degree? The degree is 1. Clear? Okay. Now as we have seen earlier, as the definition of the order of the differential equation, order of a differential equation is the order of the highest order derivative occurring in the differential equation. So here the highest order derivative is the second order derivative, so the order is 2, and degree is the highest power of the highest order derivative present in it, so the degree is 1. Now come to the second one. Here we see that the highest order derivative is 3 here, and we see that this differential equation is not a polynomial equation in its derivatives, because here the y prime, that is dy over dx, occurs as a power of this exponential number. Clear? So this is not a polynomial equation, so therefore the degree is not defined. Clear? Okay. The third one, here we have the highest order derivative is dy by dx, so the order is 1, and the highest power of this highest order derivative is 2, so the degree is 2. Clear? Again, in example 4, the highest order derivative is the first order derivative, so the order is 1, and the degree is not defined because it is not a polynomial equation in its derivatives. Clear? Because here dy by dx occurs inside this sine function here. See, we have a sine of y prime here, so this equation is not a polynomial equation. And now similarly in example 5, the highest order derivative is 4, so here we have the order as 4, and again the degree is not defined because this equation is also not a polynomial equation in its derivatives, because here also see the derivative occurs with this cosine function cos of y triple prime. Clear? Now viewers, here let us take one more problem. Here we see that we have this differential equation in a form where a radical sign is involved. Clear? So whenever we have the square root sign or the radical signs or fractions, then to find the degree of such a differential equation, we must make the equation free from radicals and fractions. Clear? So let us see how to find the degree of this differential equation um, when it is given in this form. Clear? So the what is order? Order is simply here the highest order derivative occurring in this equation. So this is second order, so the order is 2. Clear? Now let us find the degree. So we'll squaring both sides, we get 1 plus dy over dx square, and we have here 3, and here we have d square y over dx square, and when we square both sides, this here we get 4. Okay. Now we see that from this equation the degree is 4. Clear? Because the degree of the differential equation when it is defined is the highest power of the highest order derivative present in it. Clear? And now viewers, let us find the order and degree of this differential equation. Clear? Now this equation can be written as y is equal to, say, y prime plus 5 divided by y prime. Clear? Where y prime is dy over dx. Now here we see that this y prime occurs in the denominator. So let us rearrange this equation by multiplying both sides by y prime. Clear? So if we multiply, we get y times y prime, and here we'll get y prime square, and this is plus 5. Clear? Now this equation can be written as y times dy over dx, and this can be written as dy over dx whole square plus 5. Okay. Now from this equation 3, we see that the order of this differential equation is 1, because the highest order derivative is the first order derivative. So dy by dx here. So order is 1. And what is degree? Degree of this differential equation is 2. Clear? Now viewers, let us take one more example. Here we have to find the order and degree of this differential equation. Now here this differential equation has the radical sign, and that is we have the power as 1 by 2. Here we have 1 by 2, and here we have 1 by 3. Clear? Okay. Now our first aim is to remove or make free this equation from the radical signs. Clear? So we'll take the LCM of 2 and 3, and LCM of 2 and 3 is 6. Okay. Now taking power of 6 on both sides, we get 1 minus dy over dx, and this is square, and we have here 3, and we have 2 d square y over dx square, and here we have 2. Okay. So 1 minus dy over dx square, and the whole power is 3, and here we have 2 times d square y over dx square whole power 2. Now we see that the order of this differential equation is 2, because we have the highest order derivative as second order derivative. Clear? And the degree of this differential equation is also 2, because the highest power of this highest order derivative is 2. Clear? So viewers, in our next lecture we will be dealing with some more concepts in differential equations.